Have you ever experienced that surprising little shock when touching a doorknob, or noticed how your hair stands on end after taking off a hat? These everyday phenomena are tiny demonstrations of electric force in action. This fundamental interaction governs how charged particles attract or repel each other, and understanding its magnitude is crucial in all areas of electrical engineering. The standard SI unit of electric force is the Newton. Just like the force of gravity or the push you exert on an object, electric force is quantified in newtons. The reason the Newton is the standard unit lies in the fundamental nature of force itself. Electric force, often described by Coulomb's law, is a physical interaction that causes an acceleration or deformation of an object. Coulomb's law precisely quantifies this interaction based on the magnitude of the charges involved, the distance separating them, and a constant known as Coulomb's constant. Since this law calculates a force, its result must naturally be expressed in the SI unit for force, which is the Newton. This consistency ensures that electric forces can be directly compared with other types of forces in the physical world. Understanding that electric force is measured in newtons helps you to conceptualize its impact. When you calculate the force between two charged particles, the result in newtons tells you the strength of that push or pull. This is invaluable when designing circuits, analyzing electric fields, or predicting how components will interact. For instance, knowing the force allows engineers to determine stress on materials, design shielding for sensitive electronics, or even predict the trajectory of charged particles in devices like cathode ray tubes. An interesting detail is how electric force relates to electric field strength. While electric force is measured in newtons, electric field strength is expressed in newtons per coulomb. This unit illustrates that an electric field describes the force that would be exerted on a hypothetical 1 coulomb test charge placed at a particular point. It is a field characteristic, independent of the test charge's magnitude, acting as a force per unit charge. So the Newton is not just about the force itself, but it is also foundational to understanding the broader concept of electric fields. Grasping that the Newton is the SI unit for electric force is more than just memorizing a definition. It provides a clear, quantitative basis for analyzing and predicting the behavior of charged particles and electric fields. This understanding forms a bedrock for deeper studies in electromagnetism, allowing you to accurately calculate the pushes and pulls that drive everything from microelectronics to large-scale power systems.